Okay, hello everyone. In today's video, I'm going to continue the series for statistics. Okay, in today's video, I'm going to talk about units of measurement, a review, and also observational studies versus experiments, also sampling techniques, and also source of bias. And for the sampling techniques and source of bias, I'll be explaining all of it. It will be on the next episodes. So let's get started. Levels of measurement, if you remember, so there are variable types: categorical, numerical. Categorical is split into nominal and ordinal, and numerical is split into discrete and continuous, which is continuous split into interval and ratio. The levels of measurement here are nominal, ordinal, interval, and ratio. So what's a nominal? So nominal is the data that consists of names, labels, or categories only. So it doesn't have a hierarchy or a specific order. For example, is eye color, and maybe names of, I mean, car, the car's brand. That's nominal. How about ordinal? Ordinal data that can be arranged in a specific order, but the difference between data values either cannot be determined or are meaningless. So this is has to be a specific order. For example, like grades. Grades have F, uh, uh, E, and then D and C, and there's B and A. So it has to be in order. So A is the highest and F is the lowest. And also another example would be the econo- economic economy, like ranking, like um, the poor and the medium and the rich. Okay, now interval. Like ordinal, but the differences between value are meaningful. There is no natural zero starting point. So zero here doesn't mean there's an absence of zero. So, for example, the degrees in Celsius or Fahrenheit. If we're talking about degrees Celsius, zero means what? Freezing point. That's the freezing point. So zero doesn't mean nothing. It means a freezing point. That's an example of an interval. A ratio, it has all the properties of an interval data, includes true 0 point, where zero means the total absence of the quantity. For example, like weight. So weight, if zero weight, that means the object is weightless. So there's an absence of the quantity there. Okay, that's for levels of measurements. Next up is observational studies versus experimental. So observational studies is you observe and measure a specific characteristic, but you do not attempt to modify the subject being studied. So you just observe the object without tampering with it. So example is tracking the sleeping habits of 500 teenagers over a year to see if it correlates with their school grades. Okay, and experimental, you apply some treatment to the subjects and then observe its effect. So you are like messing with the subject. It requires a treatment group and a control group. often receiving a placebo. Example is splitting 100 teenagers into two groups, or one group is forced to sleep 8 hours and the other one 6 hours, then testing their alertness. That's for observational, and this is experimental. Next up is sampling techniques. So first, simple random sampling. So every member of the population has an equal chance of being selected. So out of 15 people, the probability of getting selected is equal because maybe you're using a machine. So the benefits, it's highly unbiased because every individual has exact same chance of being picked, um, and it minimizes selection bias. And also, it's statistically ideal. It makes it very easy to use standard statistical formulas to analyze the data. An example of it would be drawing 100 employees' IDs out of a digital hat, or some sort of software, maybe Python. Next is stratified sampling. So the population is split into two groups called strata, and sampling are randomly drawn from each subgroup. So as you can see in the picture, this is a subgroup, and you choose randomly. The benefits are guaranteed representation. So ensures that minority or smaller subgroups are not accidentally left out of the sample, and there's high precision. It often produces more precise and reliable results than a simple random sampling because it reduces sample to sample variability. And an example of it would be sampling an equal percentage of freshmen, sophomores, and juniors. Okay, that's for stratified sampling. Now moving to cluster sampling. So the population is split into sections or clusters. A few entire clusters are randomly selected, and everyone in those clusters is surveyed. Benefits is cost effective and practical. Perfect for large scale geographic studies, and instead of flying all over the country to interview 100 random people, you can fly to three specific towns to interview everyone there. And there's easier administration, simpler to manage logistically, and simple random or certified, yeah, than simple random or certified sampling. An example of it would be randomly picking 5 city blocks and surveying everyone on them. So instead of surveying the whole city, you survey 5 city blocks. Next would be systematic random sampling. So selecting a random sorting point and picking every cave person from a list. So the benefits are simple and quick. So it's very easy to execute on the spot without needing complex random number generators. And it's even distribution. It ensures the sampling is spread evenly across the entire population list. So, for example, inspecting every 50th bag of chips of a factory assembly line, or in this case, there's 12 samples, and we have to select every fourth person selected, which is that means the fourth person and the eighth person and the 12th. Next is convenience sampling. So choosing an individual who are the easiest to reach or closest at hand. The benefits is fast and cheap, and it requires almost no planning, budget, or advanced setup. And it's great for pilot studies, helpful for a quick proof of concept or a test out survey questions before launching a massive and expensive study. An example of it, so it's surveying the first 20 people. you see in a, let's say, a coffee shop. That's an example of convenience sampling. Now we're going to get into sources of bias. So bias occurs when your sample does not accurately represent the population, leading to flawed conclusions. So first is selection bias, or a selection sampling bias. Your method of choosing the sample systematically excludes a certain group. So doing an online poll about internet access, that means people without internet are excluded, so they cannot do the online poll because they don't have internet. So that's selection bias. Voluntary response bias. The sample consists of entirely of volunteers who choose to respond. This usually attracts people with intense polarized opinions. Example would be Yelp or Amazon reviews. People usually write them only if they love it or hate the experience. And the final tool would be non-response bias, which is selected individuals refuse to pers- participate or cannot be reached. If their opinion differ widely from those who did respond, your data is skewed. How about response bias? Participants give inaccurate or dishonest answers. That yeah, that will most likely happen in a um, let's say a Yelp review. This happens often with sensitive topics where people answer with what they think is acceptable rather than the truth. Well, that happens a lot on the internet. Okay, so that's it for this video, and thank you. I hope to see you on the next upload.